Okay, looking at 902 this lesson, and I shared the wrong screen. Where is it? Here we go. Okay, so looking at trig identities, or in particular, the reciprocal trig ratios. So reciprocal trig ratios are the reciprocal, or reciprocal basically means the inverse of sine, cos, and tan. So just like numbers, if we had, let's say, x to the power of -1, we have the inverse or the reciprocal of x, which is 1 over x. So x on its own as a fraction is the same as x on 1. So as you can see, when we inverse or we raise to the power of a negative, we find the reciprocal. We're essentially just swapping our fractions around. So 1 and x swap. So x becomes the denominator rather than the numerator, essentially. And on that theory, we also, or that's how we get our reciprocal trig ratios. So we call them three new names, which you may have seen before, may not. So we got cosec or cosecant, which abbreviates for cosec. We have secant, which abbreviates for sec. And we have cotangent, which abbreviates for cot. So the feature of that word indicates reciprocal or the opposite. So if we're saying that cosecant is a reciprocal of sine, well, sine theta on 1 would be sine theta. We just don't write the divide 1, and because we take the reciprocal, all we're doing is we're swapping it. So then we get our 1 on sine theta, or the reciprocal of sine. So that can also be written, or as you see it on your calculator, cosec is the same as sine inverse, right? So we're taking our sine ratio and we're inverting it, basically. So cosec is the word we use to describe the inverse sine. And same thing for our other two. So sec secant is the inverse of cos, and cotangent is the inverse of tan. So essentially you're just swapping the fractions around. Or as we see here, sine is usually SOH, or SOHCAHTOA. Sine is usually opposite over hypotenuse, but because we're inverting it, or we're doing the reciprocal, we actually get H over O, or it's basically just inverting the fraction, and that's where we get our hypotenuse over opposite. So if you're finding the cosec of an angle, you're finding the inverse or the opposite of the sine ratio. Now, in regards to remembering which one is which, it's quite, or there is no real tricky, or there is no cheap way of remembering it. You just sort of have to remember, if anything, secant or sec looks more like it should be sine, right? And cosec looks more like, the word itself looks more like cos. But essentially, yeah, we're just swapping those around. So the way I kind of remember it is, yeah, I just sort of remember in order. So I remember that's number 1, that's number 2, that's number 3. And we start with the sine one, and then we have the cos one, and then we have the tan one. And obviously the word cotangent has tan in it, so we know that that's the reciprocal tan function. And the other two we just have to remember, or sometimes you just sort of have to remember that it's what you kind of think it is, but it's the other one. So yeah, unfortunately, there's no like real easy way of remembering those ones. Okay, so the reciprocal ratios have the same signs as their related ratios in the different quadrants. So in other words, the inverse of sine is positive in the same quadrants that sine is positive in. So we remember our unit circle. We've got our all stations to central. So cosecant, which is our inverse sine ratio, is positive in the all and in the sine quadrant. So sine indicates quadrant 1 and quadrant 2. Our cos would therefore be positive in all and the cos quadrant, and tan, obviously, the all and the tan quadrant. So that does not change, even though we're inverting. The positive and negative operations do not change. So let's have a look at how we can find these inverse trig ratios if we're given a triangle. So looking at question A, we're asked to find cosec, sec, and cot for this triangle. So what I'm going to do first is, firstly, I'm going to write cosec is my inverse sine. So it is my inverse sine ratio. Now, sine ratio is usually O over H, but because we're taking the reciprocal, we need to flip that around. So cosec, or cosec of our angle, I forgot to put angle in, is the same as H over O. So looking at our triangle, we just take our H and our O values, plug them into to our fraction. So H is 5 over our opposite of 3. So 5 over 3. Sec is our inverse cos ratio. So 1 over cos, or cos inverted. Cos is usually A over H, but since we're inverting it, we need to go H on A, which, looking at our triangle here, our hypotenuse is 5, our adjacent side is 4. So that will give us our ratio, 5 on 4. So sec theta equals 5 over 4, or sec A. Doesn't matter if we're using A or theta, just means unknown. And our cot, or our inverse tan ratio, tan is usually O over A, but we're inverting it, so we've got A on O, or 4 on 3. So they're quite easy given these values. And let's have a look at let's have a look at question B, where we're not given the triangle, or we have to work out our triangle first. So looking at question B, we've got sine and we've got a negative fraction. So that tells us that sine must be negative, which hints at what quadrant it should be in. And we're given the fact that tan is positive. So I'm going to revert back to my unit circle, which I should really be drawing every question. So I've got all stations to central. So the fact that sine's negative tells me it has to be in the bottom 2 quadrants, because sine's positive in the top 2. And the fact that tan is positive indicates that it must be in T quadrant. And we're asked to find the exact ratios of cot, sec, and cosec. So firstly, I'm going to use my fact I'm given here. I know that my triangle happens in this quadrant, and I know that sine's value in that quadrant is 2 over 7. And sine, remember our theta is in here. Sine is opposite over hypotenuse. So opposite being 2, hypotenuse being 7. And again, I'm just going to use Pythag to work out what my missing side value is. So I'm going to do 7 squared, take 2 squared, gives me 45. Root 45 is not a nice number, so I'm going to leave it as root 45. Sorry, we got a decimal, so yeah, so I'm just going to leave it as root 45 for now. Okay, now I'm asked to find cot, sec, and cosec. Now, to avoid confusing myself, I usually do it in order. So remember, I go cosec, sec, and then cot, until you get comfortable understanding that, you know, cosec is your sine, inverse sine ratio, sec is your cos and cot. So let's do it in order. So cosec cosec theta is our inverse of sine. So we take sine and we flip it upside down. Sine is usually O over H. or in this case, because we're flipping it or inverting it, we're doing H on O. And that gives me, my hypotenuse is 7 and my opposite is 2. So it's the opposite fraction that sine is, as you can see from the original question. Sec ratio or sec theta is our inverse of cos. So cos is usually A over H, so we will get H over A, or inverted. H being 7, A being on root 45. With my fraction, where are we? Yeah, so with my fraction here, that's what we call a irrational denominator. So what I want to do is I want to get rid of that. So I'm going to multiply my fraction through, or I'm going to rationalize the denominator, sorry. So multiply, looking back at our previous chapters from last term, I multiply by root 45 on root 45. So I get 7 root 45 on 45. Running out of space there. 9 times 5 gives me 45. So I can then bring that out. So I've got so I've got 7 root 9 root 5 on 45, which gives me 3. 7 times 3 gives 21. Gives, let's continue it over here, gives 21 root 5 over 45. And then to simplify that even further, I'm going to get, or divide each by 3. So I should get 7 root 5 over 15. Okay, that looks a bit messy there. So let's continue. We'll continue at the top and we'll do our last one. So we've got our cot ratio. So cot is the inverse of tan. Tan is usually O over A. So we're looking for A over O, or swapping our fraction. So our adjacent side down here was our root 45 on A over O, so 2. And because I don't have a surd on the bottom of the fraction, I don't need to worry about rationalizing the denominator. So that's perfectly acceptable there. I could even bring it back down like what we did here and do that equals to root 9 root 5 on 2, which equals to 3 root 5 on 2. But that's not 100% necessary. One thing I did forget to add on though, which I just had a look at, is my sign, or make sure I put the appropriate sign on. So when we did cosec, we looked at sine, and sine in tan's positive quadrant. Tan's the only one that's positive. So my sine fraction should have been negative. My sec was cos. Cos in this quadrant again is negative. So my final answer should have been negative 7 root 5 on 15. And my cot ratio is my inverse tan, which means it's positive where tan is. So I can leave this fraction here as a positive result. So that's one thing to obviously remember, is make sure you put on whether your sign or your fractions are positive or negative. And last question, looking at stating whether state the quadrants where cosec is negative. Cosec is our inverse sine function, so it is negative where sine is negative. So we're looking at quadrant T and C down the bottom, or quadrants 3 and 4. So 3 and 4 will be the answer here. So remember, the inverse ratios, the signs stay the same as your normal ratios. Cool. Moving on to the next part of information. Now, complementary angles. Considering when we're drawing our triangles within the unit circle, we're always getting right-angled triangles. We can use complementary angles to work out various values, or to quickly work out if we're swapping between different ratios, or if we're asked to find the equivalence of one ratio in another, which will make sense in a second when we go over it. So essentially we have our triangle. We have our triangle here. We've got angle ABC, side ABC, which, remember, the little letter is always opposite the big letter. And therefore, if we have our angle in our unit circle of theta, and this is a right angle, that's 90 degrees. So theta, or this angle, angle in the bottom corner plus the angle in the top corner must equal 90 to make sure our triangle equals 180. So therefore, whatever theta is, our opposite angle is going to be our 90 minus that theta, or that angle. So if theta was 30, this angle here would be 90 take 30, or 60 degrees. So using that and looking at our angle theta here, we can see that sine is our O over, or our B over H, which is C. And we work our way down and we can get our complementary angles for each of our ratios. So we've got our standard sine, cos, and tan here. And then we've got sec, cosec, cot, which are our inverse ratios. And we see that they are the equivalents of, and then, sorry, we have the same down the other side for our opposite angle, or our 90 minus theta. So as you can see, sine equals B over C should be the same as cos B over C, and etc. So that's not, these ones aren't very important, but what's important is our complementary angle results, and we get those from our findings up the top here. So sine theta is the same as cos 90 minus theta, which we saw up the top. Sine theta was B over C, cos 90 minus theta is B over C. Tan here is the same as cot 90 minus, so tan's fraction B over A is the same as cot's fraction here, B over A, or 90 minus theta. Cool. Moving on, let's see how we apply those. So I've got a couple of questions here, and I'm asked to simplify tan 50 degrees, take cot of 40 degrees. Okay, well, using my complementary angle results, I can use this fact here to help me work out this problem. So I've got tan 50 degrees, take cot 40 degrees. Okay, so let's use the fact that we know tan theta is the same as cot 90 minus theta. So if we're looking at theta in this example, theta is 50 degrees. So tan, writing into my ratio here, tan 50 degrees equals the same as cot of 90 take 50 degrees. So I know that tan 50 degrees equals cot of 40 degrees. So tan 50 is the same as cot 40. So what I'm going to do is I'm going to take this cot 40 and substitute it into where tan 50 is, because they're the same value. So essentially I'm getting cot 40 take cot 40, and something take another thing just gives me 0. So that's quite an easy one there. So I'll pop 0 as my answer in. Let's get rid of this so we can do the second question. So second question is we need to find the value of m if sec 55 equals cosec 2m minus 15. So again, we're going to have to use one of our complementary angle results to help us work this one out. Okay, let's get rid of this. Okay, so having a look at the complementary angles, I'm looking at sec equals cosec. So I'm looking at this angle result here. So sec 55 degrees equals cosec 2m take 15. So let's fill that in. So using this, let's fill in sec 55 degrees. Let's find its value or its cosec value equals cosec of 90 minus theta. And remember our theta here is 55 degrees. So 90 take 55 degrees. So therefore sec 55 equals cosec of 35 degrees. Okay, so now I've got my cosec or my value of sec 55 in cosec. I'm just going to plug them back in here, into my original. I'm going to replace sec 55 with cosec 35, and then I can solve to find m. So plugging it back in, remember I'm replacing sec 55 with my new value here. So cosec of 35 degrees equals cosec of 2m take 15. And when I have my two cosec values here, I can just get rid of them and solve. So 35 equals 2m take 15, which I'm now going to add 15 on both sides. This is just simple algebra now. I get 50 equals 2m. I need to divide through by 2 to find m, so m gives me 25. And that should be my answer, so I could plug that in up here. I could also check that this is correct, because 2 times 25 gives 50. 50 minus 15 gives me 35. So cosec 35 equals, and we found out that sec 55 equals cosec 35. So yes, it does check out, which means we must be right. Okay, moving on to our next. Now we have a couple of identities we can make. So if we remember back to our last, or 901, we knew that sine equals x, cos theta equals y. Sorry, there should be a theta in here. And tan theta was x over y. So given that tan theta equals x over y, sine equals x, and cos equals y, that must mean that tan equals x over y, or in other words, tan equals sine over cos, which is quite handy. And given that fact, we can also determine cot. Remember, cot is the inverse of tan. So all we're doing to get cot from tan is we're inverting this fraction, or we get our cos over sine instead of sine over cos. So these two identities help us out, and you can remember these identities from this fact here, from the fact that sine was x, cos is y, tan is x on y. So therefore, tan must be sine divided by cos. Cool. So knowing that, we're going to simplify this question here. So we've got sine theta. Let me write a bit higher so we've got a bit more working out room. We've got sine theta times cot theta, and we need to simplify it. Well, I'm going to use my fraction here. So cot theta is the same as cos over sine. So I'm going to replace cot theta with my fraction. So sine theta multiplied by cos theta on sine theta. Remember when we're multiplying, this would be over 1. So multiply the top together. So I get sine theta cos theta over 1 times sine theta, which is just sine theta. And from here, I can cancel out. So I got my divided by and multiplying by sine. They cancel out. So my simplified version is just cos theta. And that would be my answer. So simplifying sine theta multiplied by cot theta is just cos theta. So if I needed to find sine by cot, I would just find cos of our theta there. Perfect. So there are a couple of other identities. We've got the Pythagorean identities. So our unit circle, which was, remember our circle about our origin, and it has a radius of 1, is given by this formula. So as we explored in our assignment, x squared plus y squared gives a circle, and then its value that it equals is the radius. So in this case, 1. And because of Pythagoras' theorem, and because going back to our sine theta equals x and cos theta equals y, I can just simply substitute those into my circle formula, and we get this value here. So I replace x squared, I replace x with cos, so I get cos theta squared plus my y, back to front, but same sort of difference. Yep, so cos squared plus sine squared equals 1. Or, in other words, a shorter way of writing is just getting rid of the brackets and putting the squared on our cos instead. And from these is where we get from this fact is where we get our identities. So there are 2 other identities that can be derived from that identity. So from this identity, we can derive these 2 down the bottom. So let's look at this identity here. I am taking my original, which is cos squared theta plus sine squared theta equals 1, and I'm dividing both by cos squared theta divided by cos squared theta equals 1 over cos squared theta. I then can cancel, that's not very neat looking, let's get rid of that now. I can then cancel out my cos thetas. Cancel out my cos thetas. That gives me 1. And sine over cos here, or sine squared over cos squared, or sine over cos, if we remember back to the tan identity we just learned. So tan is sine over cos, so tan squared must be sine squared over cos squared. So I can replace this with tan squared theta. And remembering back to my inverse trig functions, 1 over cos is the inverse of cos, or sec was the inverse of cos. So 1 over cos squared would equal my sec squared, equals sec squared. And that's where I get this identity from. Now, if I do the same thing, and let's have a look at, let's just change color here. So we've got, it looks a bit different. Let's have a look at this identity, which we just find by dividing our original identity by sine squared. So let's write out again. So we've got cos squared theta plus sine squared theta equals 1. So let's divide everything by, or divide through by sine squared to get our next identity. Sine squared, divide this term by sine squared, equals dividing this term by sine squared. Don't have to actually put my equals there. Divide sine squared theta. Okay, so looking again, sine squared theta over sine squared theta equals 1. Cos over sine back to my tan identities is the cot identity. So cot is cos over sine, so cos squared over sine squared must be cot squared. So I would replace this with cot squared theta. And 1 over sine squared, or 1 over sine is the inverse of sine, or the cosec. So 1 over sine squared must be cosec squared equals cosec squared theta. So cot squared theta plus 1 gives me cosec squared theta. And as you can see, that is my third Pythagorean identity here. So I've got 3 identities and they are summed up for us down here. And they can also be arranged. So cos squared plus sine squared equals 1 can also be arranged. So if we had our cos squared theta plus sine squared theta equals 1 can also be arranged to give these other 2, which aren't very important to remember because so long as we remember this, we can work it out. So if I wanted to find cos squared, I'll just take sine squared from both sides. So I'd have cos squared theta equals 1 take sine squared theta. So that gives me first one. Or if I wanted to find sine squared, I'll just subtract cos squared from both sides, and that will give me my second. Cool. So looking at the last questions here, I've got 2. I need to prove that cot x plus tan x is the same as cosec x times sec x. So a few things to remember here. Okay, so let's have a remember, or let's remember. Let's not have a remember, we'll remember. So okay, remember back to our trig identities. We had tan equals sine theta on cos theta, and cot, the inverse of tan, is just that flipped around. So cos theta on sine theta. So here, let's look at the left-hand side to prove that it is the same as the right-hand side. So I'm going to replace cot x or cot theta with my value here. So cot is the same as cos over sine. So I should have cos, and let's keep x just for consistency, plus, okay, replace tan x with my tan. So sine x over cos x. Now what I want to do is I need to add those fractions. So to add the fractions, I need to multiply left by this, or I need to cross multiply first. So I'm going to do cos x times cos x on top on the left, which gives me cos squared x over sine x cos x. Plus, and sine x times sine x gives me sine squared x over sine x cos x. Okay, from this point here, I have I have similar squared over sine squared. Yes, okay. So I'm going to bring this together as one fraction. So I have cos squared x plus sine squared x over sine x cos x. And looking at the top, I've got cos x, cos squared x plus sine squared x. Using my Pythagorean identity, I've got cos squared x plus sine x equals 1. So I can simply just replace this value here with 1. So I would write, therefore that equals 1 over sine x cos x. From this point, I can split this into two separate fractions. So I would, let's continue that up here. So I would get 1 on sine x multiplied by 1 on cos x. So I've just taken these fractions and split them down the middle. And from this point, I know that 1 over sine x is the inverse sine, or that is cosec. So that becomes cosec. And 1 over cos x is the inverse cos function, which is sec. So cosec x multiplied by sec x. And that therefore proves that cot x plus tan x is cosec x sec x. So they're getting quite elaborate here, and we have to call on quite a bit of knowledge or just known facts. So these can be quite tricky, and sometimes it can be hard to work out where to go next. So yeah, so just be careful with these ones. Let's look at part B. I might do that on a new page, actually, save me having to erase all of this, if I can get it working. Gives me a bit of space up here. Okay, so part B. Okay, so part B, I have to prove that the left-hand side equals 1 over 1 plus cos x. Okay. So let's start with the left-hand side. So we've got 1 take cos x over sine squared x. Okay, so let's use this identity we have here, which we have derived from this by taking cos x from each side. So sine squared x equals 1 take cos squared theta. So what I'm going to do is I'm going to replace sine x here with 1 take cos squared theta. So let's write that out. So this would give me 1 take cos x over 1 take cos squared x, or cos squared theta. I'm just replacing theta with x just for consistency. So on this point, I then am going to split this into two fractions. So I'm going to get cos squared x, I'm going to split into 2. So I've got 1 take cos x over 1 take cos x 1 plus cos x I'm then going to get 1 1 take cos x divided by 1, sorry, 1 minus cos x divided by 1 minus cos x gives me 1. And then I'm left with this on the bottom. So let's fix that bit. So 1 over 1 plus cos x. Or as we can see now, we have proved. Again, these are quite tricky and you won't see too many of these questions, but it is important to work towards them. So make sure you're asking questions in class as you work through them, making sure that you have an understanding and that you check all identities to make sure, or to have a look at what we can sub in. So we've got our tan identities, and then we've also got our Pythag identities as well. And remembering that you can rearrange these to give us other forms that might assist, depending on what we're given in our fractions, to try and find common numerator and denominator values. Cool. We'll end the meeting there.